What's going on, guys? Welcome to part 2 in this tutorial series where we're going to be making a game in Unity 3D. We're going to be starting where we left off last video and creating a simple movement system for the player. If you have any questions, make sure to let me know, and yeah, let's get on with the video. So there's nothing we need to do on start right now. I'm going to go ahead and just remove that. The only thing we want to do is on update, we want to be moving the player. So how do we move the player? Well, if we come back, as you can see, the position, let me close all this, the position is a part of the transform. So we want to be affecting the position, which is a part of the transform. So somehow we need to access the transform and then the position of that transform. And the way we do that is actually really easy. We just say transform. As he already autocorrects, you can press enter or tab to fill that in. And then again, we want position. So just say transform dot position. And here's the position. And at the end of every statement, I forgot to mention that, at the end of every statement, you want to put a semicolon. And then up here, when we declare the variable, we can give it a value initially. But yeah, sorry. So say transform dot position. Now this doesn't actually do anything. I can make this a statement. I guess it does get mad at me because we have to do something with it. Right now, it's not doing anything. So how do we do that? We can say plus equal, or we can say equals, and again, we need 3 values because it's x, y, and z. So how do I give it 3 values? Well, this is what we need. We need some sort of format that does this, and that's actually called vector3. So let me go ahead. I'm gonna make this private, vector3. POS just for position equals 0, 0, 0. I'm gonna explain all this in a second, so let me just write it down first, and then we can say position. Okay, so what does this mean? Well, vector3 is actually a Unity specific, so you won't find this in other places. But a vector is just a direction. It's a value with a direction. I believe a vector. It's basically a vector in Unity is just a decimal number. It's actually a float. And what a float is, a float, well, I'll just say health, because we already have a speed, that's why I was yelling at me. So a float is just a decimal number. In Unity, there is something called a double. I'll just call this money or whatever. It doesn't matter. There is a difference between these two. Double, again, this is the variable type, so we're saying, okay, this is a type of double. This is the variable name. I think I forgot to mention that too. It does not matter what the name is. The name of the variables don't matter at all. The only thing that matters is these first two. After that, you just have to make sure that the value of it is related to the actual type. Again, that's why we can't put a 5.2 in here, because an int is not a whole number. But the name can be whatever you want. But yeah, so public double money equals 5.0. And as you see, I have an F here. I don't have an F here. When you use float, you have to put an F. Basically, a double takes up more memory, more space. So Unity uses floats. I'm guessing that's why Unity uses floats instead with everything they do. So any of these values in here, that's a float, 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 that's a float. All these are floats. Everything's a float. So when you're working with Unity, you're pretty much always just using floats. And all a vector3 is just 3 floats. And you have to declare it as a new vector3 because it's not a traditional variable type. It's actually more of an object. But that gets a bit complicated. Just know that when you're making a vector3, you just have to say that it's a new vector3, and then you can give it the 3 values. And these are actually three floats. So I can say it's 3.2f, 1.2f, 6.8f, just like that. But if I put a 6.8, it will get mad at me because Unity does not use doubles. it wants a float. And if you scroll over these little underlines, it'll usually tell you what you're doing wrong. So just make sure you put an F. But these are all just decimal values. So when we say this, 0, 0, 0, say we want the player to go to 0, 0, 0. Every single frame, we want to be stuck at 0, 0, 0. We just say transform.position equals position. So equals 0, 0, 0. So this will be changing to 0, 0, 0 every frame. So if we click play, as you can see, we're stuck in the ground at 0, 0, 0. If I try to move it, it's not going to move because every single frame, it's going back there. Now it's going to actually condense into one line. We can just say right here, new vector 3, 0, 0, 0. Like that. And again, we said transform.position equals new vector 3. So we're changing the position to something. Now, what we can do is we can say, we can't do transform.position plus new vector 3. Because this is just a value. It's not actually changing anything. We can say equals transform.position plus new vector 3. So what this is going to do is, say we put a 1 here in the x value, it's going to be adding 1 to the x position every single frame. But this is pretty complicated. Instead, what you can do is just say plus equals, and then you don't have to have this transform.position. So this is going to add whatever's after it to this value, and of course set it equal to that value. And as you see now, when we play, it'll be really, really fast, but it will zoom off the screen like that. So awesome. So that's how we get it moving. One thing you might ask is, well, why can't we do transform.position.x and then plus equals 1? This is actually a read-only value. Yeah, I don't know. But basically, you can't actually affect x. I think it, yeah, you can only use it for something. So say we make a new variable, private float x value, okay? We don't set it to anything. So this is empty right now. This doesn't have a value. We can then say x value equals transform.position.x. And you don't have to writing this down, typing this out. Just watch for now, and I'll tell you when we start getting into the actual movement. I want to explain all the basics because, again, I understand how it feels to not understand everything. And so if I go from the very beginning, I feel like it'll make a lot more sense. But if I say x value, I can say this, but I can't actually change this x value. I have to do it in a vector 3 format like this, which is a little annoying sometimes, but that's okay. But yeah, so again, transform, we're just accessing the position. All right, we're adding a new vector 3. Okay, so a vector 3 is just a variable that holds 3 of these values, so it works perfectly with this. Doesn't actually mean that a vector 3 is a position variable. It just holds 3 values, so we can easily do this with it and set the 3 values or add to the 3 values. Okay, so hopefully that makes sense. Again, we'll be doing all kinds of different stuff in here. Movement and position is actually one of the most complicated things to code in a game. That's why I'm going so slow, so you guys can kind of understand it. I'm going to go and delete these so we keep things simple. And I'm going to replace this one with speed. Now if we click play, you will go zoom in off the screen. Now, one problem with update. Okay, one problem with update is that it happens every frame. Now, if you've ever played a game, your your frame rate will vary, right? It'll go from like 200 frames a second and even down to 2 frames a second if you get a bad lag spike. So this is happening every frame. It's gonna be really, really choppy. So if we want to keep it smooth, or it'll get really choppy when we get frame drops and things like that. If we want to keep it smooth, we want to keep it consistent, and don't want the player, glitching out of bounds or something like that when our frame rate spikes, we can actually add fixed update. And fixed update doesn't rely on your frame rate, but it actually has a fixed frames per second. So usually people will tell you, put all your physics in fixed update. That way it's not so buggy, you're not glitching through things. And that avoids us having to do some more smoothing out later on. So now we click play. He's still zooming off. We can just change his speed to something like 0.5. Oh, I'm sorry. It won't let me put that. We do actually want this to be a decimal. So we will make this a float. And then typically you'll put like an F after. Even you always have to put an F after if you add a decimal. You don't have to if it's a whole number, but usually common practice you do. So I'm just going to add 5F. Then we come back, it'll let us put in a decimal. So we slow him down. Now as you can see, he's moving smoothly, one direction, but we can't control him yet. I can't use WASD. So how do we get the mouse input? Well, that's where we bring in something called an if statement. Now, if statements are pretty simple to understand. Basically, we just say if something, then something. Now, I kind of forgot to mention that all of your methods and all of your if statements, anything that needs to be enclosed or any code that needs to be enclosed in some sort of something will be enclosed in curly braces. And don't forget your semicolons at the ends. I know I've already mentioned that, but that's something I always forget. Everyone always forgets. But yeah, so basically we say update, so fixed update. Anything that we want to happen in the fixed update, in that certain amount of time per second. I think it's around 30. By default, you can change it. We'll just say 30 times a second. We want this to happen inside of it. And then again, the class, this is the script, and we want everything inside this to be a part of that script. Okay, now if something, right? So we'll say if I am, oh my gosh, I am hungry, right? Then we want to eat, okay? And that's basically how it works. So if I am hungry, we will eat. And we can bring this back to a math equation. Again, we can say, and now that we can actually use a variable, we'll just say int x equals 5. So if x equals 5, if you're ever comparing a value, you have to use 2 equals. Don't forget that. I always forgot that. Everyone always forgets that. But yeah, so when you're declaring it, it's 1 equals. When you're checking to see if it's true, if you're checking if x does equal 5, you need those 2 equal signs. If x equals 5, well then we can do this here. I'm just going to cut it, Control X, and I'm just going to put it there. So this will always be true because x is 5, and we're not going to change it. If I make this public, then we can actually change this in the inspector. So right now x equals 5, and we're saying if x equals 5, then move. And if I come back in here, x right now, x equals 5. If I click play, we start moving. If I change x to 2, it'll stop moving. But if I put it back to 5, it'll start moving again. So again, only when x equals 5 will this statement run. So now how do we check for a key input? Because that's really what we want to do. We want to check A, D, W, S. Well, there is something nice, and I'm going to introduce you guys to the Unity docs. Which I'm not sure how to get them from their website, but if you just type in Unity docs, they will come up right here. The scripting reference. That's what we want. Okay, here we go. This is where you want to be. If you ever search something up, like say we wanted to search up transform.position. And then it comes up in the scripting API. And this is going to tell you all the different stuff it does, right? The world space position of the transform, and then it just shows you all different kinds of stuff you can do with it. It doesn't tell you it's a vector 3. Oh, it does. There we go. Vector 3. So it tells you what type it is. You can even click on this and go in here. There's all sorts of different stuff. I haven't used half of this stuff, right? So don't stress. Don't get too overwhelmed. But basically, if we come in here and we type in input, right? Say we want input. and we wait for it. There we go, input. And we have get access, all that kind of stuff. We just click input. It'll have a bunch of different kinds of stuff that we can use. But if we scroll down to the properties or the methods, again, these are variables. So properties are variables. Methods is actually is a function, which I'm going to explain in actually just after this. But we can come in here, we can say, we have get access raw, get button, that's more what we're looking for, get button maybe, get button down. The only difference between these two is get button happens if you hold the button down, it'll keep going. Get button down only happens when you click the button once. Yeah, during the frame the user pressed down the button, while this would be whenever the button is down. We also have key. Now get button, you have to use Unity's input system. Get key, we can just declare the key that we want. So if we say if, okay, and again we're accessing input, so we just type in input and then dot, and the method we want is get key. Okay, and then open close these parentheses, get key. What key do we want? We want D. And D doesn't come up, but if you actually type in key code, and then you can click dot D. It's just a little thing you have to do. You can access a key code, and that key we want is D. So we're just saying if we get key, so anytime this key is down, then we want to move in that direction. If we save this and go back, click play, and we press D, anytime we have D down, it's going to move over to the side. Awesome. And now I'm going to explain methods. Methods or functions, whatever you want to call them. What I'm going to do, I'm going to go ahead and add a couple lines here. So void fix update is a type of method. It's a built-in method though. So Unity already has, already knows how this works. But we can make our own method. And if we come down here, type void, and we'll just say move. Open and close our parentheses. Why did it do that? Again, Unity likes to do that. Move. Please do not move. Okay. I'm gonna get rid of that for now. So void move. Right, I'll go ahead and add it back. Private void move. It looks very similar to a variable. So what exactly is a function? Well, you can think of a function just like a block of instructions, right? Like if you say, make breakfast, right? We can say, make breakfast, right? Ignore all the errors. This isn't how you actually do something. I'll make it one word, so don't think about it. Make breakfast. What do we do when we make breakfast? Well, I'm just going to make these as comments so they don't actually, are actually a part of the code. When we make breakfast, this involves getting a bowl, pouring the bowl of cereal, and then, I don't know, drinking water. Right? Well, so that's all a part of making breakfast. Now, if I went and told someone else, or if I had these instructions in my head, right? I know that making breakfast involves getting a bowl, pouring a bowl of cereal, and drinking water. And someone else told me, make a breakfast. They wouldn't have to say anything else. They wouldn't have to tell me to do all this. I would already know. They just tell me make breakfast. I'll do it all. And that's exactly what we can do. And this is exactly what we can do for ourselves. When we wake up in the morning, we're like, okay, I need to make breakfast. Well, I don't have to tell myself, I have to do this. We're going to go through and do it. But I already know what is involved in making breakfast. And that's exactly how this works. I can say make breakfast, okay? And then I can actually call this up here by just saying make breakfast. You have to open and close your parentheses. And yeah. So that's it. So we say make breakfast. Now every frame we're going to get a bowl of cereal, pour a bowl of cereal, or get a bowl, pour a bowl, drink water. This actually isn't going to do anything because these are comments, but that's how it works. That's how functions and methods work. It's just a block of code that can run. The other cool thing we can do with methods is functions, right? So a function in math, right, you might have something like Again, don't worry about where I'm putting this. I am just going to put it here. We say x plus, or we'll say y equals x plus 2, right? So we give it an x, right? And we do x plus, so say x was 2, right? And then we add 2, that's 4. So y would actually output 4. So the reason why there's a void here, and again, private is the same reason, private, and you can make it public if you want to access it with another code. If you want to call that function from another code, again, like if a friend asks me, I'll make breakfast. If you want that friend to be able to ask, if you want a different script to be able to ask this script, you have to make that public. We're not going to worry about that. We're going to keep it private. But the reason why we have void here, we can actually make this a variable. We can say int, right? But this will actually return an integer. Just like a function would. So say this is our integer function, right? And we plug in a 2. Okay, so we'll say x is also an int, right? So we say int x, and these right in these parentheses are where we put our parameters. X would be an input. This is where we put our inputs, right? So okay, we need some sort of input, and we'll give it x. Now, what does x do? Well, it's going to return, right? This whole function is going to give us y, which is just x plus 2, and so then we'll just say x plus 2. We'll say int y, which again is just a new variable. We'll just call it y equals x plus 2. Make sure we put our semicolon, and then we can just say the keyword return y. This will return y, which is very useful, because what we can do with that is, again, this is going to want us, oh well, okay, I'll call this function to make more sense now. Function, okay, it wants an integer. It'll tell us that right here. We need an int x. We'll give it 2, and this will actually output a 4, because again, we take in the 2, we added 2, and then we just return y. We don't actually need to put this. We can just say return x plus 2. I was just doing that so it made a little more sense. But yeah, that's why you might see them call this functions, and so this will actually equal 4, and we can figure this out. I'm gonna introduce the console to you guys. So we type in debug.log, and then we can actually input something into this. And if I give it this debug.log, that's just gonna output a log to our console. And so if I go into fixed update, it's gonna do this every 30 times a second. So you'll see a bunch of stuff here, but as you see, 4, it does actually give us 4 in our console, and this is what debug.logs look like, and these are very, very useful. You're going to use them all the time when you're debugging, but yeah, so that's how functions work. But we're going to go ahead and make this just a move. Let's call it move, and we're just going to do this for the sake of keeping organized. You don't have to do this, not at all. I usually don't actually, but I'm just going to do it for this tutorial so that you guys kind of get used to using functions. And right here, we can just call that move. Okay, it's void. Void means it doesn't return anything. Sorry, I kind of forgot to mention that. Void means that we're not returning an integer or whatever. And then we're gonna put this into here. So I just Control X, Control V. So now we say if. Okay, so every single frame we're going to be calling move, this block of code, and we're going to be checking in this block of code if we get this button down, then do this. So we go back in here, click play. As you see, everything worked the exact same. Now we just have to set it up for the rest of the controls. So I'm just going to go ahead and copy and paste this 3 times, I guess. We'll click A. And here, what we can do is we can just subtract. You can either do a minus here, because we have to go the other way. So we can just apply a negative speed, or we can subtract the speed off the x. They're both the same thing. Because these would be negative as well, but since they're 0, they're the same thing. So I'm just going to go ahead and say plus equals, and I'm just going to add negative speed. I feel like that seems a little, makes a little more sense. And now we'll say W. Right, and then we're actually going to want to be moving on the x-axis by speed, and then D I'm sorry, S, and we're going to do the same thing. We're not moving on the x-axis, but we are going to move negative speed. And that's all. So if we come back here, our axes are actually shown here. We have the x-axis is the red, and then there's the axis is the blue. You can see that up in your little tool right here. And then your y-axis is up and down. So I'm going to move this out of the way. So again, if we press W, we're going to move this way. If we press S, we're going to move this way. And then D and A. And that's basically just what we told it to do. So now if we click play, and we can move it around, just like that. And that's basically it. You got a little controller movement. Obviously, it's not doing a whole lot right now. But in the next tutorial, we'll look at doing collisions and things like that. And yeah, so let me know. If you have any questions, make sure to let me know in the comments. I'll get back to all of you guys, try to help out. Because I understand that a lot of stuff can be really complicated. Sorry if I was rambling a bit. Again, I'm trying to get that basis, trying to get you guys to kind of understand and get this basics. And again, we're going to be doing this stuff over and over and over again. So if you are a little bit confused, don't worry about it. We're going to be doing a lot more of this kind of stuff. Lots to go. So yeah, thanks for hanging out. Thanks for watching the video. And I'll see you guys in the next one. See ya.